Day 171 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. You already know what it is. We're back again another day, another LeetCode problem. This time we're at day 171 and we're still going strong, y'all. So I hope y'all feeling disciplined. Hope y'all feeling consistent because that's what you're going to need to get through this LeetCode journey, y'all. But don't worry, we'll get through it together. But before we get started, don't forget. Bring your mouse right over here and click that subscribe button for me, y'all. Then after you click that subscribe button, go in and smash that like button for me, y'all. And then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. I need y'all to drop 2 bank emojis in the comment section so we can run up this engagement and help push this content out to a broader audience, y'all. As Swift community members, it's up to us to help the Swift community to grow. And one way we could do that is to share this content with whoever we could find that will watch it, y'all. So tell a friend to tell a friend to tell a friend to tune into this channel and let's do some LeetCode. So let's see what the problem says today. Today we have question number 888, fair candy swap. Fair, fair exchange ain't no robbery. You know what they say. So this question is called fair candy swap. It's a difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well because we're all here trying to learn. And if you don't understand the solution at the end of this video, then you probably did not learn anything, and that is not what we want, y'all. So let's see what the question says today. The question says, Alice and Bob have a different total number of candies. You are given 2 integer arrays, Alice sizes and Bob sizes, where Alice sizes of I is the number of candies in the ith box of candy that Alice has. Bob sizes of J, or Bob sizes J in the square brackets, is the number of candies in the jth box of candy that Bob has. Since they are friends, they would like to exchange 1 candy box each so that after the exchange, they both have the same total amount of candy. The total amount of candy a person has is the sum of the number of candies in each box they have. Return an integer array answer where answer 0, square bracket 0, or index 0 is the number of candies in the box that Alice has that Alice must exchange, and answer index 1 is the number of candies in the box that Bob must exchange. If there are multiple answers, you may return any one of them. It is guaranteed that at least one answer exists, y'all. So I know that was a lot to take in, but let's get into the examples so we can make it make sense because it's really not that difficult. In example 1, we have input Alice sizes that equals an array 1, or it equals an array of integers 1 and 1. Bob sizes equals an array of integers 2 and 2. The output is 1 and 2. The output is 1 and 2 because it says right here, return an integer array answer where answer answer index 0 is the number of candies in the box that Alice must exchange. So right here, index 0 is 1. That's how many candies, or that's the number of candies in the box Alice must exchange. So index 0 corresponds to Alice sizes right here. We must move one of these ones over to here to Bob sizes. Then it says answer index 1 is the number of candies in the box that Bob must exchange. So Bob has to take a 2 and give it to Alice, but we're just going to return it in the array. So we're going to put the box that Alice has to give Bob in this array, and we're going to put the box that Bob has to give Alice in this array, right? So that's why the answer is 1 and 2, because if Bob, let's just say they swap these right here, right? They swapping candies, fair candy swap. Fair exchange ain't no robbery. You know what they say. So if we give Alice, or we take Alice's 1 box, give it to Bob, we take Bob's box with 2 candies and give it to Alice. Now Alice will have 3 candies. Let's put it over here so we can make it make sense, right? So Alice has 1 and 1. Bob has 2 and 2. If we give Alice to let's say we do it like this, right? And we give Alice's box with 1 candy to Bob, right? So now Bob has it like this. Then we take Bob's candy and we give it to Alice. So now Alice's looks like this and Bob's look like this. We take this one, we give it to Bob. Then we take this 2, we give it to Alice, excuse me, this should be a comma. So yeah, we take this 1, we give it to Bob. Now Bob has this. Then we take this 2 from Bob, give it to Alice. Now Alice has this. So now Alice has 3 candies and Bob has 3 candies. And that seems like a fair candy swap to me. So I hope that makes sense to y'all. If not, let's look at the second example. In example number 2, we have Alice sizes. She has an array of integers 1 and 2. Bob sizes is an array of integers 2 and 3. The output is 1 and 2, right? So we take this 1, give it to Bob. Now take this 2, give it to Alice. So now so now Alice would have 2 and 2. Bob would have 1 and 3. 2 plus 2 is 4. 1 plus 3 is 4. That's a fair exchange. That's a fair candy swap right there, because at the end of the day, they will both have 4 candies. So let's look at example 3, where it seems like a trick question, but it's not that tricky. So, excuse me, y'all. In example 3, we have input Alice sizes equals an array of integers 2. Bob sizes equals an array of integers 1 and 3. The output is 2 and 3, right? So this, even though there's only 1 box of candy over here, right? Say we give this box of candy to Bob. We give the 2, we take Alice's, give that to Bob. We take Bob's 3 and give that to Alice, right? Now Bob would have 3 candies over here, and Alice would have 3 candies over here, right? If we move this 2 over here and this 3 over here, they both equal 3. It will be a 3 over here, and it will be a 1 and 2 over here, and they'll both be equal to 3. And that seems like a fair candy swap to me as well, y'all. So, hence the name of the problem. Now that we understand the problem, let's get into the fun part, the part that all keeps us motivated to keep coding in the morning, the actual code, and it's not that difficult at all. The first thing we are going to do, we are going to declare a variable called set. We could just say underscore b, set underscore b. We're going to say colon. We're going to set that equal to a set of integers. Excuse me, y'all. And we're going to initialize it with a blank array. Then underneath that, we're going to declare another variable called sum. My bad, y'all. That's crazy. No, let's get back to it. So we're going to declare another variable called sum underscore a. We're going to set that equal to 0. Then we're going to declare another variable called sum underscore b. We're going to set that equal to 0. Then we're going to declare another variable called diff. Set that equal to 0 as well. Then we're going to come underneath that. We're going to say for in Alice sizes, open up the brackets. We're going to say sum underscore a plus equals a. Then we're going to come underneath that for loop. We're going to say for b and Bob sizes. We're going to open up the brackets. We're going to say set underscore b that we just created up there. And we are going to say dot insert. Open up the parentheses b. We're going to come underneath that. We're going to say sum underscore b plus equals b. Then we're going to come outside of that for loop. We're going to say diff equals, open up the parentheses, sum underscore a minus sum underscore b. Then we're going to say divided by 2. Then we're going to come underneath that. We're almost done, y'all. Almost done. We're going to say for a and Alice sizes. Open up the brackets. We're going to say if set underscore b dot contains. Open up the parentheses. A minus diff, come outside of the parentheses, open up the brackets. We're going to say return square a comma a minus diff. Boom. Then we're going to come right here and we are going to say return square bracket 0. Boom. Let's run it. See if that runs. You know, you can never be too sure with this stuff, but look at that, y'all. So let's submit it. Make sure it stays submitted. Let's see. Boom! 4 milliseconds beats 100% of users with Swift. Y'all already know those are the numbers I like to see. We're riding down the highway past all of the brokies in our brand new Bugatti that we just bought off this programming that we learned, y'all. That's what I like to see. And you know what else I like to see? I like to see y'all tomorrow here for another day, another LeetCode problem. See y'all then.